The last method that we're going to talk about on how to solve a system of equations is called elimination. Remember, in a system, we are looking for the value for x and y that will satisfy both equations. Okay, so we're trying to find two numbers, x and y. Remember our three methods. We've already talked about graphing, talked about substitution. And so now we're looking at the last method, which is elimination. Remember, we have three solutions. One solution, we will get a value for x and y. It'll look like an ordered pair. No solution, both variables will eliminate, and we will have something that does not make sense. So for example, 0 equals 7. Infinitely many solutions, both variables will eliminate, and we will end up with 0 equals 0. Or something that does make sense, right? Because 0 is equal to 0. All right, so we looked at steps to substitution in the previous video. In this video, we're looking at steps to elimination. Okay, so up until this point, we've talked about slope-intercept form of a line, y equals mx plus b. Step one says to put both equations in standard form. So standard form is another way to write a linear equation or a linear function. Standard form is ax plus by equals c, right? And a, b, and c are going to be numbers. So we could have something like 3x plus 4y equals 12, something like that. So we're trying to put both equations in that form. And we're going to line up those equations when we do that. So we'll have two equations that'll both have the x terms, y terms, equal sign, and then the numbers or the constants at the end. We're going to determine which variable to eliminate. We're looking for variables that have opposite coefficients. Right, so for my x terms, if I had a 3x in one equation and a negative 3x in the other equation, those are opposites. My x's are going to eliminate. If I had a negative 4y and a positive 4y, then I will line up, or I will eliminate my y variables and go from there. Okay, so we're always going to add the equations vertically. Okay, so this will eliminate one of the variables. That's what the opposites will do. When we add opposites together, they equal 0 or they cancel out. Kind of have a 3B step here is if we don't have opposites already, we have to create opposites. It says if the coefficients aren't already opposites, then we have to multiply one or both equations by a number or two different numbers that will make opposite coefficients. Okay, so we need to multiply one or both equations by a number that will make opposite coefficients. And then part 4 just be to plug in our answer to step 3, which is our x or y, back in the other equation or either of the two equations to find the other variable. So after we do these 4 steps, we should have an x equals and a y equals if there is one solution. So we're going to look at a couple examples today for elimination. And here they are. So we'll look at example number 1. And remember our steps. So step 1 is to put both equations in standard form. Well, we have ax plus by equals c, ax plus by equals c. We're going to determine which variable to eliminate by looking for opposites. So if I look here, I have a negative 4x, positive 4x. Those are opposites. So I like to start off by drawing a line under both equations, and I write a big plus sign out on the left. So this tells me I'm going to add my x's together, add my y's together, add the constants together. So negative 4x, positive 4x, those cancel. So now I do negative 2y plus positive 8y. So I have negative 2 plus 8, so I get 6y equals. Negative 12 plus negative 24 gives me a negative 36. So now I've solved for y. Divide both sides by 6, and I get y equals negative 6. There's one part of my answer. So now I take y equals negative 6 and I plug it back in to either one of my equations to solve for x. So if I do that, let's say I'm going to use the second equation. It doesn't matter which one you use. 4x plus 8 times negative 6 equals negative 24. So I get 4x plus, this would be negative 48, 8 times negative 6. So I could say minus 48 equals negative 24. So now I add 48 to both sides. Those 48s cancel. So I'm left with, I'm going to come up here. I have 4x equals, I have negative 24 plus 48, which gives me a positive 24. So I divide both sides by 4, and I get x equals 6. So my final answer, I have x is 6, so that's 6, comma, y is negative 6. So there is my final answer. All right, example number 2. I have one equation, x minus y equals 11, that's in standard form. Ax plus by equals c. My other equation was in slope-intercept form, y equals negative 2x plus 19. So I need to adjust or rearrange the variables in my second equation to be able to line it up with the first equation. So this one I'm going to add 2x to both sides. Okay, so I want to put my x term first. So 2x, y is positive, and that equals 19. So now I can just rewrite my first equation right here, x minus y equals 11, and now I'm ready to go. So my opposites here are the y terms, 1y, negative 1y. So I can add those. 2x plus x is 3x, the y's cancel, equals 19 plus 11 gives me 30. So I have 3x equals 30. Divide both sides by 3, and I get x equals 10. So now I can take that and plug it into either one of my equations. All right, I'm going to do the second equation because it's already set up to tell me what y is equal to. So I'd say y equals negative 2x plus 19, and I'm going to take this 10, I'm going to plug it in right there for x. So I get y equals negative 2 times 10 plus 19. Y equals negative 20 plus 19. So y equals negative 1. So now I have x is 10 and y is negative 1. And there's the last two examples. Example number 3, we have 2x plus 8y equals 6 and negative 5x equals 20y minus 15. So first thing, our first equation is in standard form, so we can go ahead and leave it as is, but the second equation is not. So we need to move our 20y to the other side. We do that by doing the opposite. So this equation becomes negative 5x minus 20y equals negative 15. My first equation was 2x plus 8y equals 6. Okay, so I look here, and I don't have opposites. Okay, so I have to create opposites. Can I multiply 2 by anything that's going to give me negative 5? No, not a whole number, an integer, something that's easy to work with. And I can't do the same for 8 either. So I'm going to have to multiply both equations by something. I can multiply both equations by the same number, different numbers. It does not matter. My goal here is to create opposites. So think about my x terms, 2 and 5. What's a common multiple of 2 and 5? Well, 10, right? So how could I make this negative 5x become negative 10x? I'll multiply by 2. And how could I make 2x become 10x? Multiply by 5. And I have to multiply all three terms by 2 or by 5. So 2 times negative 5x gives me negative 10x minus 40y equals negative 30. I multiplied all three parts by 2. On the bottom, I do 5 times 2x, which is 10x, 5 times 8y, which is plus 40y, and 5 times 6, which is 30. Now look what happens here. I have opposites, so I'm ready to add. Negative 10, positive 10x, cancel. Negative 40y, positive 40y, cancel. So I'm left with 0 equals negative 30 plus 30, cancels, 0. So notice what we have. 0 equals 0. Is that a true statement? Yes, it is. So we would say that our answer is infinitely many solutions. And that's our answer because we got something that made sense, right? We ended up with 0 equals 0. All right, our last example. Both equations are in standard form. However, we don't have opposites. So let's eliminate x, right? It doesn't matter which one we start with. We could eliminate x or we could eliminate y. How can I make negative 3x become positive 3x? Right, I gotta multiply by negative 1. So I gotta multiply all three parts by negative 1. So basically I'm taking the opposite sign of all three of these terms. So this becomes 3x minus 3y equals negative 9. And I can rewrite my first equation right below it. Negative 3x plus 3y equals 4. Now I'm ready to add. Positive 3x, negative 3x, cancel. Negative 3y, positive 3y, cancel. So I'm left with 0, just like I was over here. However, What's negative 9 plus 4? That's negative 5. And 0 does not equal negative 5. So we would say our answer is no solution. So those are our 4 examples of solutions we could get. For one solution, we had really 3 examples. One solution, we got 6, negative 6, 10, negative 1. Down here, we had infinitely many solutions because we got 0 equals 0. And over here, example 4, we got no solution because we got 0 equals negative 5, and we know that is not a true statement.